Welcome to Tech Talks. Our admin edition today is focused on Splunk Operator for Kubernetes. Effortlessly deploy, scale, and manage Splunk. Splunk Tech Talks is a series of short webinars that are deep dives for technical practitioners. We value you, our customer, and want you to continue in your Splunk journey. Our experts to help create these best practices, and we want you to leverage them in your daily role. Hi, I'm Judith, product marketer for the core platform, and I'm excited to discuss the features and benefits of Splunk Operator for Kubernetes and introduce my colleague, Patrick Ogden.
Hi, I'm Patrick. I'm the product manager for the Splunk Operator for Kubernetes.
Thanks, Patrick. Today, we're going to give you an introduction, go through the features, go through requirements and best practices, show you a demo on how to get started, and touch on the benefits, as well as go through additional resources to help you continue your journey with Splunk. Our team will be available for Q&A throughout this time over the Q&A widget within your screen. And if you watch a recorded version of this webinar, please continue the conversation through the Tech Talk discussions in the Splunk community at splunk.com/techtalk.
Before Judith jumps into introducing the features, let me explain a little bit of why we actually created the Splunk Operator for Kubernetes. So customers, historically, with Splunk Enterprise, would have to set up and code a lot of their automation themselves, either through Puppet or Ansible or another automation platform. The other portion that we were trying to address here is that when you need to expand or even contract resources within Splunk at the search and indexing tier, that was a bit tedious and difficult to do and a lot of administrative steps. Also, to set up the monitoring process using tools such as our own monitoring console, there was some manual intervention involved there that we've attempted to remove with the Splunk Operator for Kubernetes.
Now, with Splunk Operator for Kubernetes, you can easily deploy and scale Splunk on your choice of cloud environment. It provides automated installation, letting you bring Splunk to any part of your organization, streamlines administration of your environment by supporting centralized monitoring and management, plus auto-scaling capabilities to accommodate your dynamic data needs. Splunk Operator for Kubernetes provides automated setup and deployment on your choice of public or private cloud provider. So regardless of what your cloud environment looks like, Splunk Operator for Kubernetes is flexible and works with public providers, including Amazon EKS, Google GKE, Microsoft AKS, and private ones, including Red Hat OpenShift, HP Ezmeral, and VMware Tanzu offerings. It also allows for easy scalability to accommodate future demand. This includes you can instantly scale out of search heads and indexers with the Kubernetes horizontal pod autoscaler to help future-proof your investment. Conveniently build distributed Splunk clusters, automatically attempt recovery of Splunk cluster components upon failure, implement disaster recovery with support for Splunk multi-site clusters. Also, it provides management tools to make Splunk administrators' jobs easier. You can centrally manage cluster secrets and passwords. You can easily monitor with automatic configuration of the Splunk monitoring console, and also efficiently store data using the tightly integrated Splunk Smart Store. And of course, directly access documented examples for common Kubernetes ingress service configurations. Now let me pass it back to Patrick to dive in deeper.
So how does this all work? We've been spending the last several years internally at Splunk using containers to automate and use our CI/CD pipeline more efficiently. So a lot of what you see here is actually an outgrowth of those efforts internally that we built automation and actually the open source Splunk Ansible project, and also the Docker container, which you can also see on GitHub, and we've actually supported as a single instance for several years. The real revolutionary thing here is that we can now stitch together distributed Splunk environments using just a couple of lines of YAML. I think maybe this environment is 20 or 30 lines of YAML and is actually a fully fledged distributed Splunk environment. So we define our license manager, our cluster manager, and actually the number of indexers in our indexer cluster here, and then tell the operator to actually deploy it. And what happens on the back end is that Kubernetes is based upon what you tell the pods that you want for resource allocation and for their limits and memory and CPU counts. It is going and scheduling the Splunk pods for the various components and supporting components like the search head cluster deployer and the license manager out into the running Kubernetes cluster, and then subsequently associating the services together using the Ansible plays and some of the other automation that we've built, such that you don't have to manually tell the search head cluster about its indexer targets for searching. All of that is built in and associated between services. So for requirements and best practices, we've actually fully documented the version requirements and hardware requirements on our GitHub page. It actually looks very similar to a non-Kubernetes Splunk environment, either running on VMs or bare metal, when it comes down to CPU, vCPU counts, and memory requirements. We do actually require the Smart Store feature just because that makes the scale up, scale down operation at the indexing tier a lot more efficient when we don't have to move as much storage around. Now I'm going to jump into my demo environment and show you the operator in action.
I'd like to show you a demo of the Splunk operator for Kubernetes. We'll start with a relatively simple single instance deployment and then move up to a distributed Splunk environment, a cluster. So first, the best place to go find current information about the Splunk operator for Kubernetes is on our GitHub page. And if you go to the main README and navigate down to the install section, you'll actually see the install string. So you can just grab this and drop it into your Kubernetes environment. And this will install the Splunk operator container. We can go into the environment and verify that the actual container was installed and is running correctly, and it looks like it's already up. So the next step here is actually to go ahead and install a Splunk instance. So there's a couple of different ways to do this. To do it very simply, to just get a single instance up, we can just use this sort of inline method. This is going to create a single instance Splunk deployment, and we're just going to call it S1. This example is actually also documented on the GitHub page. So we've created our single instance deployment, and actually if we get pods again, we can see the standalone Splunk instance coming up here, and it should be ready just in a few minutes, or in a few seconds actually. While that's coming up, we can actually do one other thing, and that is get the default or get the administrative password for the Splunk deployment. So we actually embed a couple of different secrets into the Kubernetes secrets file that's associated with the pod. So if you actually run this command, and this is also captured in the GitHub page under the password section, we'll see a couple of defaults that we ship with. There's an HEC token, a couple of other things that we use for communicating between components when we're in a clustered environment like the search head cluster and the indexer cluster. But for now, really all that we're interested in is the Splunk web administrative password. So what we're going to do here is actually, as the pod has come up, double check again to make sure it's up and running. It looks like it's come up there, and actually you'll see the monitoring console pod come up next to it. We'll talk a little bit more about that later. But what we want to do right now is we just want to port forward the single instance that we just created called Splunk S1 Standalone to our local machine. And we're going to grab this admin password and go over here. And we should be able to log into our Splunk instance using the password that we just grabbed. And we can, and that was successful. Next, we're going to take a look at a more complicated example involving a distributed environment, a clustered Splunk environment that uses a search head cluster and an indexer cluster. For a Splunk administrator, this should look pretty familiar. There's different components that comprise a distributed Splunk environment, some for licensing, some for control, some for content distribution. We define all of this before we actually create the distributed Splunk environment via the operator in a YAML file, and this should make sense. We first need to have a pod that acts as a license manager. So we have created this here and actually have defined a config map, which is a Kubernetes concept that allows us to actually load the license in from file. In fact, if we go and look at the Splunk environment or at the Kubernetes environment right now, if I do kubectl git cm git config map, you can actually see how this looks, and to create it is pretty straightforward. We actually just recreate it, but the command is found in the actual documentation. It's just create a config map and then use either a demo license or an enterprise Splunk license, and you can actually put commas into this and add multiple at the same time if you need to. But for the license manager pod, that's how we set it up within this singular piece of YAML. The next piece is we need a cluster manager. We need something for the indexer cluster peers to talk to. So the cluster manager is set up as such, and it's pretty straightforward. This is where it starts to get interesting. We make reference to the license manager that we just created from the cluster manager, and instead of having to either write some kind of script that does this or write some automation of yourself, this is all taken care of when the cluster is created with the Ansible plays that are actually embedded and part of the operator ecosystem with the Docker container and the Splunk Ansible automation. The next piece is we actually have to define the nodes of the indexer cluster. In this case, we've said that we want 3 indexer cluster nodes, and just in a similar pattern, we make this association from the indexer cluster nodes back to the cluster manager right here in the YAML definition. So that tells the indexer cluster nodes which cluster manager to go talk to for rebalancing and all the good stuff that the cluster manager does, and then also obviously for content distribution, for pushing out apps and whatnot into the cluster. We actually don't even need to define the license manager here. It is actually acquired. The individual indexer nodes acquire their licensing through the cluster manager. The final piece is the search head cluster, which is actually, we don't have to define any replicas here if we want 3, because a search head cluster by definition has minimum number of nodes or minimum number of instances, pods in this case 3. If we wanted 4 or 5 or 10, we could actually also describe this here, but very similar to the other examples, we make this these references such that the search head cluster can automatically go start talking to the indexer cluster and create the distributed search environment automatically through the Ansible plays by talking to the cluster manager. And then obviously we need to be able to authenticate to this thing, so we need the licensing reference as well. I've actually added another piece down here that we'll take a look at a second, and that is how we do the content distribution to the search head cluster from this file. But for now, I've already actually applied this. It takes maybe 5 or 10 minutes to come up in my environment, and we can actually just go take a look at it now if we do. And here's the environment as it's running. So here are all the necessary components. I mentioned the monitoring console. We'll take a look at that in a second. We've got 3 indexers, a license manager, The search head cluster deployer, which pushes content out into the search head cluster, actually comes up automatically, and then obviously acts as the content distribution point for the search heads. The interesting thing about the monitoring console pod is that it's automatically configured. So in fact, if we went and looked at the actual running deployment, so I do a port forward from the monitoring console pod. Our monitoring console is actually already configured and set up because we are declarative about what the cluster is supposed to look like. And then as the cluster changes, we can actually track this and update these different roles and whatnot as the search heads, indexers, and other things come and go. So there, fortunately, in this environment, is no more hand configuring when an indexer or a search head is added here. Obviously, also very interestingly in this environment is being able to expand and contract it quickly. Just in this example, we can actually patch the running cluster with a couple of commands that will add nodes. So in this case, if you recall, I actually started my cluster with 3 indexers. In this case, I'm actually going to add an additional one just with this. So now that I've patched it, if we go back and look at the pods again, here is the other indexer pod coming up. And very similarly, if we want to do one for the search head cluster, we can add an additional one here and go verify that our fourth search head cluster is coming up and getting ready to start functioning. The next thing I wanted to show was how we install apps in the distributed environment. As you can see, I'm actually port forwarding one of the search head clusters, or one of the members of the search head cluster, to my local machine just to go over and verify that I actually don't see any apps on it. The search head cluster deployment is actually completely clean right now. There's nothing on here but just the stuff that's out of the box. So what I want to do here, and I'll go back to the YAML I referenced, is that within the spec for the search head cluster, I can tell the search head cluster what apps I want to install default out of the box for when I'm creating my cluster. So I can do this in a couple of different ways. There's one method that uses a config map, similar to what we did with actually the Splunk licenses, but that's pretty severely limited in size, and most Kubernetes environments, it's limited to 1 megabyte for an app, and as we know, many apps can grow to large sizes. So the current preferred method is to actually just pass it a URL. In fact, I'm just mounting an S3 bucket here with an app that I've just brought down off of Splunk base, and when actually I go and apply this, it will communicate with the search head cluster deployer. So let's go ahead and do that. All right, so the search head cluster change here, it says configured, and here in a minute we'll be able to verify that actually the app was picked up from the URL from the S3 bucket that I had it in. It's actually via Ansible play brought down to the search head cluster deployer, put in the necessary location on the file system of the search head cluster deployer for content distribution, and then subsequently pushed out into the cluster. Now we're back. It's been a couple of minutes, and now my lookup editor app that I put out in my S3 bucket on my URL and defined in my search head cluster CRD is now out in the environment. So that was the app getting pushed out. The other nice thing here is you can go follow along if you wanted to go take a look at the actual output from the, say, the search at cluster deployer. So we go logs. All of the Ansible plays that are running actually in their times are output to the pod logs, and you can see the lookup editor app actually getting pushed out. So the other couple of things I wanted to call out are that we do have some examples of some of these more complicated distributed environments out on our GitHub page. We're going to start populating this with more items, some of the multi-site examples pretty soon. But you can start to look at these and help you get started with how to make the associations between some of the different services instead of piecing them together directly from the documentation. We actually also have an example for how you can use a standalone and put out 100 heavyweight forwarders if you wanted to. The other thing I would call out as interesting is looking at the custom resource guide. So this defines all of the variables that you can define for the different Splunk components for the different custom resources. There are some common specs such as, say, the system resources, the requests and limits that you want to actually put on the pod, and some other things such as storage, how much storage you want the var and the etc directory to actually have. And then things that are specific to specific CRDs. So for the license manager, there were a couple of things that we called out, and then obviously things that the Certec cluster, CRD, and indexer cluster will take as inputs. Finally, I wanted to mention I've been demoing this using port forwarding, which is easy, but obviously in a real environment, a distributed environment, you would want to configure ingress. So we've gone to the extra effort of putting together some documentation on how to do this with an example for Nginx and actually with Istio. Obviously, this is critical in a Kubernetes environment for not only accessing Splunk web distributed, especially if there's a Certec cluster that is behind a load balancer of some kind, but also obviously for the Splunk to Splunk and HEC inputs for actually getting data into the cluster. So something to actually go out and pay attention to. Thanks for listening to my demo, and I'm going to pass it back to Judith.
Great. Thanks, Patrick, for that demo. Now let's walk through some of the powerful benefits. You can bring Splunk to any part of your organization. It is easy to leverage Splunk in all parts of your enterprise with simple push-button deployment that requires no additional resources or tooling. Installation is easy across any number of servers and any types of environments, and you can automatically scale as your needs change. Additionally, it lets you unleash your DevOps team with reduced complexity. It frees up your IT resources with automated tasks, maintenance, and scaling, and you can say goodbye to time-intensive upgrades and enjoy a more efficient, streamlined process. Plus, advancing your environment has never been simpler with Splunk and third-party product integrations. Lastly, it enables you to effectively and centrally manage your Splunk environment. You can track all your information and passwords in one secure, easy place, directly store your data with tight integration to SmartStore, and back up your data with support for multi-site clusters, and simultaneously manage all your cloud environments. We're about ready to wrap up this tech talk, but before we do, I wanted to quickly share the resources available to you to continue your journey. You will receive these assets in a follow-up email as well as the recording. So we have the Splunk documentation. We also have the very useful GitHub documentation to help with every step of getting started. Definitely check that out. Plus, we have a variety of Kubernetes-related blogs to give more details on all things Kubernetes. Don't forget that we have an incredible community of Splunk users on our community site. You can search the answers section on Kubernetes. You can continue the conversation for this talk within the discussion section called Tech Talks, where you'll find all the additional resources. And finally, there's Splunk Ideas, where you can submit new product enhancements or vote for current ideas from other customers. We really appreciate you taking the time out of your schedules to join us today. Please tune back in for future Tech Talks. We are excited to share the series with you.